Pluto was supposed to be simple. Too small, too far, too cold to matter. A frozen relic at the edge of the solar system. But when NASA's New Horizons spacecraft flew past it in 2015, that idea collapsed. Because Pluto isn't frozen in time. It's geologically active. Its surface shifts, its ice flows. There may even be a liquid ocean hidden beneath its crust, billions of kilometers from the sun. And if that's true, there may be even deeper secrets waiting to be uncovered. Could we really one day live on Pluto? Let's find out. Welcome to Simulation Hypothesis, where we slow things down, challenge first impressions, and follow the data wherever it leads. If you're into uncomfortable space truths and the kind of science that rewrites what we thought we knew, subscribe and stay with us, because Pluto is not what we were taught. For most of the 20th century, Pluto was an afterthought. Discovered in 1930, it was labeled the ninth planet and then quietly imagined as a frozen misfit, a distant, inert ball of ice orbiting in darkness. When it was reclassified as a dwarf planet in 2006, the emotional reaction was stronger than the scientific one. But scientifically, the message was clear. Pluto was small. Pluto was simple. Pluto didn't matter. And that assumption lasted until July 14, 2015. That was the day NASA's New Horizons spacecraft performed its historic flyby, after traveling nearly 5 billion kilometers over 9.5 years. What it sent back did more than give us pretty images. It shattered decades of planetary assumptions. Instead of a dead, cratered relic, New Horizons revealed a world that looked active. The most striking feature was a vast, heart-shaped region called Sputnik Planitia, a basin roughly 1,000 kilometers across. At first glance, it looked smooth. Too smooth. It lacked the heavy cratering you would expect on an ancient, untouched surface. That alone was unsettling. Because in the outer solar system, surfaces are supposed to preserve scars. Impacts accumulate over billions of years. A lack of craters suggests something is renewing the surface. On Pluto, at temperatures averaging around -220 degrees Celsius, Sputnik Planitia isn't just smooth, it's made primarily of nitrogen ice, not water ice nitrogen, and this nitrogen behaves differently. Under Pluto's conditions, it can slowly convect. It can flow like a glacier. New Horizons captured evidence of massive nitrogen glaciers creeping across the landscape, flowing around obstacles, carving channels. Glaciers imply movement. Movement implies internal energy. And internal energy on a body that's small and that far from the sun should be minimal. Pluto is only about 2,377 kilometers in diameter, smaller than Earth's moon. Bodies that small are expected to cool quickly after formation. Their internal heat should dissipate over billions of years. By now, Pluto should be geologically dead. But it is. Towering above its plains are mountains made not of rock, but of water ice so hard at those temperatures it behaves like stone. Some of these mountains rise 3 to 4 kilometers high, comparable to the Rockies. They show little sign of erosion, suggesting they are geologically young. Young terrain on a world 4.5 billion years old. That alone forces a rethink. Then there are the strange polygonal patterns across Sputnik Planitia, cellular shapes tens of kilometers wide. These are believed to be convection cells. Warmer nitrogen ice rising from below, cooling at the surface and sinking again. It's a slow-motion churn. Pluto is breathing. But that's where it becomes truly unsettling. Sputnik Planitia sits in a massive impact basin. Something huge struck Pluto long ago, excavating material and leaving behind this enormous depression. Normally, a large impact basin should create a gravitational low point, a mass deficit. Instead, measurements show that region is actually a gravitational anomaly. It has more mass than expected. That suggests something dense beneath it. Something like liquid water. Several planetary scientists have proposed that Pluto may harbor a subsurface ocean beneath its icy crust. An ocean tends to perhaps over 100 kilometers below the surface, insulated by ice, kept from freezing entirely solid by internal heat. And this isn't speculation pulled from imagination. It's based on models of Pluto's rotation and the way Sputnik Planitia appears to have reoriented the entire dwarf planet. Yes, reoriented. Pluto may have rolled over in response to that basin forming. The weight distribution changed, and the planet adjusted its spin axis to bring Sputnik Planitia closer to the equator. That kind of true polar wander implies a partially liquid interior capable of allowing movement. In other words, Pluto isn't a rigid frozen ball. It may be structurally flexible. Now pause for a moment. We're talking about a world so far from the sun that sunlight there is 1,600 times weaker than on Earth. A place where the atmosphere freezes and collapses onto the surface as it moves along its elliptical orbit. A world where the average temperature is colder than liquid nitrogen. And yet beneath that crust, there may be a reservoir of liquid water. Water is significant not because it guarantees life, but because it changes the narrative. Liquid water requires energy. Energy requires a source. Pluto doesn't receive enough solar radiation to power geological activity. So where does the heat come from? One source is radioactive decay. Even small bodies contain trace amounts of radioactive elements that release heat over time. On Earth, radioactive decay contributes significantly to internal heating. On Pluto, it might be enough, barely, to maintain pockets of warmth beneath thick insulating ice. Another possible contributor is tidal interaction. Pluto and its largest moon, Charon, are locked in a gravitational dance. They orbit a common center of mass outside Pluto itself. Unlike Earth and our moon, Pluto and Charon are more like a binary system. The tidal forces between them may have generated heat in Pluto's interior, especially early in its history. Over billions of years, even small heat sources can matter if insulation is effective. And Pluto's crust appears thick. But here's where the scary aspect begins to form. Because a subsurface ocean under immense pressure, isolated for billions of years, is not stable in a way we intuitively understand. It's a hidden environment, one we cannot access easily, one that could freeze, fracture, or vent in unpredictable ways. New Horizons also observed features that may be cryovolcanoes, volcanoes that erupt not molten rock, but slushy mixtures of water, ammonia, and other volatile compounds. If confirmed, that means Pluto has experienced internal eruptions in geologically recent times. Active cryovolcanism at the edge of the solar system. That's not peaceful. And then there's Pluto's atmosphere. It's thin, mostly nitrogen, and it behaves strangely. As Pluto approaches the sun in its highly elliptical orbit, ices sublimate and form a temporary atmosphere. As it moves away, the atmosphere freezes and falls back to the surface. Pluto undergoes seasonal atmospheric collapse. Entire global cycles of freezing and refreezing. From a habitability standpoint, this is extreme instability. Now let's return to the question you asked at the end of the hook. Could we one day live on Pluto? On the surface, the answer seems simple: no. The surface temperature is lethally cold. The gravity is about 6% of Earth's. Prolonged exposure would cause severe physiological changes. The sunlight is weak. The atmosphere is too thin to breathe and too unstable to rely on. Radiation levels are higher than on Earth. But here's where it becomes interesting. If there is a subsurface ocean, and if it remains liquid, then theoretically, the most stable environment on Pluto would not be above ground. It would be beneath it, under kilometers of ice, shielded from radiation, insulated from temperature swings, perhaps sitting atop a slow, cold sea that has existed for billions of years. That changes the frame entirely. Living on Pluto wouldn't mean building cities on the surface. It would mean burrowing. It would mean using the ice itself as protection. It would mean harnessing internal heat rather than sunlight. And that leads to a deeper realization. Pluto isn't scary because it's violent in the way Jupiter is violent. It's not a gas giant ripping moons apart. It's not bombarding us with radiation belts like a miniature star. Pluto is scary because it violates expectation. It is small yet active. It is distant yet dynamic. It is cold yet internally warm. And if we were wrong about Pluto for nearly a century, What else in the outer solar system are we underestimating? Because if this quiet dwarf planet can hide oceans and shifting ice plains, then the line between dead world and active world is far thinner than we thought. And that means the outer solar system isn't a graveyard. It's evolving. And if it's evolving, then we've only just begun to understand what lives or moves in the dark. And if we've only just begun to understand what moves in the dark, then the real question isn't whether Pluto is cold. It's whether it's stable. Because once you accept that Pluto is active, that it has moving ice, internal heat, possible oceans, cryovolcanic features, you stop seeing it as a frozen fossil and start seeing it as a system. And systems change. Pluto's orbit alone is unsettling. It's not a clean, circular path like Earth's. It's wildly elliptical. At its closest approach to the Sun, Pluto is about 30 astronomical units away. At its farthest, nearly 50. That's a massive difference in solar energy over the course of its 248-year orbit. During parts of that orbit, Pluto is actually closer to the Sun than Neptune. But here's the strange part: Pluto doesn't crash into Neptune. It can't. The two are locked in a 3-2 orbital resonance. For every 2 orbits Pluto makes, Neptune makes 3. It's a gravitational choreography that has likely lasted for billions of years. That resonance keeps Pluto safe, but it also keeps it in a delicate balance. If that resonance were disrupted, even slightly, Pluto's orbit could become chaotic over long timescales. And chaos in orbital mechanics doesn't mean immediate disaster. It means slow unpredictability. Over millions or billions of years, small gravitational nudges can amplify, orbits can shift, inclinations can change. The outer solar system is not static, it's dynamic and evolving. Now combine that orbital instability with internal activity. If Pluto truly has a subsurface ocean, then it is not a completely rigid body. Its outer crust may be decoupled from its interior by liquid layers. That means surface stresses could build and release in ways we don't fully understand. Fractures could open, cryovolcanic vents could erupt. Ice tectonics, yes, tectonics could slowly reshape entire regions. And unlike Earth, Pluto doesn't have an atmosphere thick enough to smooth over those changes. Everything that happens remains preserved for eons. Then there's temperature. At -220 degrees Celsius, materials behave differently. Nitrogen becomes rock-like. Water ice becomes as hard as granite. Methane and carbon monoxide freeze into exotic ices. But as Pluto moves along its orbit and sunlight fluctuates, these ices don't simply sit there. They sublimate, turning directly from solid to gas, and then recondense elsewhere. Over centuries, entire layers of frozen volatiles can migrate across the planet. Imagine a world where the bedrock itself slowly evaporates and reforms. That's not peaceful. That's transformation on a planetary scale, just slower than we're used to. Now return to the idea of living there. If humans ever attempted to establish a presence on Pluto, we wouldn't be stepping onto solid, stable terrain in the way early explorers landed on continents. We'd be entering a world whose surface chemistry shifts with orbital position. Energy would be a massive problem. Solar panels would be nearly useless. Sunlight at Pluto is about 11600 the intensity we receive on Earth. A solar farm that powers a city here would barely run a few light bulbs out there. Any settlement would require nuclear energy. Constant, reliable, high-output power. That introduces risk in an environment where evacuation is impossible. And evacuation brings us to another point. Pluto is not just far. It's isolated. At its closest, Pluto is about 4.7 billion kilometers from Earth. At its farthest, over 7 billion. Communication signals traveling at light speed take between 4.5 and 7 hours one way. A round-trip conversation could take half a day. If something goes wrong, a reactor failure, structural breach, unexpected geological shift, there is no rapid rescue. There are no nearby refueling stations, no orbiting fleet, no emergency landing zones. You are alone. But perhaps the most unsettling aspect isn't its distance or cold. It's what Pluto represents. For decades, we assumed that small bodies at the edge of the solar system were frozen leftovers. Simple, geologically dead, predictable. New Horizons proved that assumption wrong. If Pluto can maintain internal heat for billions of years, then so can other Kuiper Belt objects. There are thousands of them, some nearly as large as Pluto, some larger. That means the outer solar system might be filled with hidden oceans. Hidden heat. Hidden activity. Worlds we thought were finished may still be evolving. And that realization reframes the scariness. Pluto isn't terrifying because it's violent in obvious ways. It's terrifying because it hides complexity beneath a surface that appears lifeless. It teaches us that distance from the sun does not equal simplicity. It teaches us that size does not equal insignificance. And perhaps most importantly, it teaches us that our intuition about planetary systems is unreliable. Before 2015, Pluto was dismissed. After 2015, it became one of the most intriguing objects in the solar system. Now imagine how many other assumptions we're currently making about distant worlds. If we were wrong about Pluto, what else are we wrong about? Could icy moons harbor ecosystems beneath kilometers of ice? Could subsurface oceans persist longer than we imagined? Could energy flow in environments we once labeled impossible? The fear isn't monsters. The fear is underestimation. Pluto reminds us that even in the coldest, darkest corners of our system, energy can linger. Systems can evolve. Surfaces can shift. And oceans can survive where sunlight barely reaches. So is Pluto peaceful? From a distance, yes. From up close, not exactly. It's a world locked in gravitational resonance, cycling its atmosphere, shifting its ice plains, possibly rolling on hidden oceans, reshaping itself over geological time. It is small but not simple, cold but not dead, quiet but not inert. And that might be what makes it the scariest of all. Because if even Pluto refuses to stay frozen in time, then the outer solar system is not a frozen graveyard. It's alive in ways we are only beginning to understand.